So today we are going to discuss the review of mathematical concepts. Basically, this is just reviewing your background on the different mathematics that we are going to use in our subject. So for the outline, we have the significant figures, scientific notation, trigonometric functions, inverse trigonometric functions, and the laws of sines and cosines. Okay, so let's start with the significant figures. Okay, so why do we need, or why is significant figures needed in our subject? Okay, so we consider all measurements as inaccurate. What causes this inaccuracy is the following. We have the precision of measuring device. So it depends on the measurement instrument that we are going to use. If it is precise, depending on what we are going to measure. Also, it depends on the human error. We should also consider the faulty technique. And since these measurements are inaccurate, it needs to convey precision. So it must include degree of uncertainty. So there are 5 rules in determining significant figures. First is significant figures in a measurement include all of the digits that are known precisely, plus one less digit that is estimated. Number 2, non-zero digits are always significant. So what are these non-zero digits? These are your integers 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, all final zeros after the decimal point are considered significant. This is if it is prior to it or prior to these zeros are non-zero numbers. So you can see there the example. You have 12.740. So the zero here is considered significant. It's because it follows the non-zero digits. Okay. The same with 0.0420. So only the final zero is the significant one. Okay. This zero at the first part are not included, are not considered as significant. For the fourth rule, you have zeros between 2 other significant digits are always significant. Okay. Now, if your zero is in between 2 non-zero digits, this is considered as significant. So the zeros here now are significant, including this one, okay, since it has a final zero after the decimal point. So it is still considered as significant. For number 5, zeros used only for spacing the decimal point are not significant. For example, 100, only 1 is the significant number. The 2 zeros are not significant, okay, since this is just a spacing to the decimal point. Okay. Another one is this example. You have here 6 zeros before the non-zero digit. So only the 233 is the significant number here. Okay. So the zeros here before these numbers are not significant, okay, unless a non-zero digit is before it. So kapag merong non-zero digit dito sa unahan ng number na ito, all the zeros are considered significant. But since walang non-zero digit dito, so only numbers 233 is considered as significant. Okay, so we'll proceed with scientific notation. You can see here that an ordinary penny contains about this number of atoms. So this length of number is very awkward to work with. Okay, so it is also difficult to read. The same with the average size of an atom is about this value or this number, centimeters across. So we use scientific notation to work with numbers with very large or very small values. So for example, you can write those values in scientific notation form. This one, 2.0 times 10 raised to 22. Or the size of each atom is 3.0 times 10 raised to negative 8 centimeters. So you can transform numbers like that into scientific notation, so it is easier for us to read it. Okay, so we define scientific notation as a method for expressing and working with very large or very small numbers. It is a shorthand method for writing numbers and an easy method for calculation. Also, these numbers are made up of three parts. We call it the coefficient, the base, and the exponent. So it has a basic notation, n times 10 raised to small n. Okay, so the big N here is what we call the coefficient times 10, that's the base, and then your exponent, which is the small n, the smaller n. So your coefficient must always be greater than or equal to 1 and less than 10. So it should be numbers in between 1 and 10. Okay. Your base is always number 10, or must be 10. And then your exponent, it must show the number of decimal places that the decimal needs to be moved to change the number to standard notation. Okay, so later on, I'll show you the example of transforming standard notation, numbers in standard notation to scientific notation and vice versa. Yes, so here it is, the example. You have your translating scientific notation to standard notation. So for example, we have here 1.35 times 10 raised to 5. So this is in scientific notation. So we are going to try to change it into standard notation. So if you multiply 10 raised to 5, you will have 100,000. So just multiply it with the decimal, that's 1.35. Or you move the decimal to the right 5 times, and you will get 135,000. So that is now your standard notation. Okay, another example, now what if you have a negative exponent? So 2.7 times 10 raised to negative 3. So you move to the opposite side since it is a negative exponent. You have here 3 places going to the left. So the standard notation for this scientific notation is 0.0027. Okay. Another helpful hint, the sign of the exponent tells which direction to move the decimal. If it is positive, it means you have to move your decimal point going to the right, and if it is negative, you have to move your decimal point going to the left. Okay, so that is for the scientific notation to standard notation. Now what if we translate standard notation to scientific notation? Okay, so this is the opposite. Write 0.00709 in scientific notation. So you move your decimal point until the number should be in between 1 and 10. So let's move it going to the right 3 places or 3 decimal place. You have 7.09. Now you can set up the scientific notation. This is now your coefficient is 7.09 times 10 raised to, if how many times did you move your decimal point. So you move your decimal point 3 times going to the right. So your exponent now will be negative. Okay, so that's 7.9 times 10 raised to negative 3. Okay, so for the trigonometry, the portion of mathematics that is based on special properties of a right triangle. So in this case, we have the trigonometric functions, the sine, cosine, and tangent. So you can find this in your calculator. This one, yung naka-underline, yan siya yung key niya doon sa calculator. So we have this very famous acronym used in trigonometric functions, the SOHCAHTOA. It's SOH and then CAH and TOA. Sine is equivalent to opposite over hypotenuse. Cosine is equivalent to adjacent over hypotenuse, and tangent is equivalent to opposite over adjacent. Okay. So here you can see a triangle or a right triangle that represents the placement of the following sides. Okay. So if your angle is placed here, so your opposite side must be the opposite of the angle. And then your adjacent is the adjacent one or the adjacent side to the angle. And then we all know that your hypotenuse, if you have a right triangle, your hypotenuse is always the longest side or the side opposite the right triangle. I'm sorry, right angle. Now, if your angle is at this side, so your opposite side now is this one, and then your adjacent side is this one. Your hypotenuse is again the opposite of the right angle. Okay, so later on, I will show you example on how to use your trigonometric functions. Okay, so we'll proceed with the reciprocal identities. So this is just the reciprocal of your sine, cosine, and tangent. So we call it cosecant for the reciprocal of sine, secant for the reciprocal of cosine, and cotangent for the reciprocal of tangent. Okay, so you have there the following formulas. This is just the opposite of your SOHCAHTOA. So for the cosecant, you have hypotenuse over opposite. For secant, the hypotenuse over adjacent. And then for cotangent, you have the adjacent over opposite. Okay, so we also have the inverse trigonometric function. So this is basically different from the reciprocal of the functions. So it is, in this notation, you have -1. Okay. -1 exponent, which indicates that this is the inverse of your function. So for example, your function is sine theta is equal to a. The inverse relation now is sine -1 raised to -1. A is equal to theta. Okay. So theta here is your angle. Your A is the side of a triangle, of a right triangle. It must be one side of a right triangle. Okay, and then your theta is your angle. Okay, so what if you don't have a right triangle? So you have now oblique triangle. So these are triangles that have no right angles. So we indicate your your angles as big letters A, B, and C, and then your sides as small letter A, B, and C. So that is now our oblique triangle. Okay, so the law of sines. In law of sines, we have the following formula. It's A over sine A is equal to B over sine B equal to C over sine C. So later on, I'll show you how to use this formula. It can also be used upside down. So you can reciprocate this formula, such as sine A over A is equal to sine B over B, sine C over C. Okay, and for the law of cosines, we have this expression, A squared equal to B squared plus C squared minus 2bc cosine A. B squared is equal to A squared plus C squared minus 2ac cosine B, and so on. So this is basically a quadratic formula where you can solve sides or angles of a given oblique triangle. Okay, so I'll show you examples of this one. And for the additional guides, I already uploaded PDF files of an ebook on physics by Capnell and an additional reference for the review of mathematical concepts. So if you have questions, please don't hesitate to ask me. You can contact me through my Facebook Messenger or through our group chat. Okay, so we have here examples for the scientific notation. Change the following numbers from standard notation to scientific notation. So let's say we have 56 billion, that's 56,760,000,000. Okay, so this is now your number. Okay, so let's have an examples for scientific notation. So change the following numbers from standard notation to scientific notation. Okay, so are given for letter A. So this is the number. We are going to write it in scientific notation. Okay, so your decimal point, if you have a whole number, is placed at the final decimal place or your final digit. After the final digit, that's your decimal point. Okay, and then you move your decimal point going to the left. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's 10. And then why we stopped after number 5? Okay. It is because in writing your scientific notation, you should consider that your number now must be less than 10. Okay. So since 5 is less than 10, you have your 5 point and then the rest of the numbers. So you can write it now as 5.676 times 10 raised to 10. So this is now your decimal places that you move to the left. So that is positive 10. Okay, so that is now your exponent for your scientific notation. So you can also write this number with 3 significant numbers. In this case, this is 4 significant figures. What if you have to write it with 3 significant numbers or 3 significant figures? So you just round off your last number. Okay, so you have 5.68 times 10 raised to 10. Okay, so this is now 3 significant. Okay, and then if 2 significant, you round it off again. You have 5.7 times 10 raised to 10. Okay, so this is now 2 significant numbers. Okay, so that is how you write your scientific notation. For the next example, this number 0. You have here 6 zeros and then 902. So you write it in scientific notation. Your decimal point is placed here. It's already placed here. Okay. So you move it going to the right. 1, 2, 3,
4, 5, 6, 7. Okay, so you stop at 9. 9 is less than 10. Okay, so you can write it 9 point, you include 02 here. So 9.02 times 10 raised to, if how many numbers you move going to the right, which is 7. Okay. It's 7. 1, 2, 3, 4, 5, 6, 7. Now this is negative 7. Now why negative? Because you move your decimal point going to the right. Okay. Kaya siya naging negative. Ito, you move your decimal point going to the left. Okay, so that's going to the left. So this is a positive exponent. Okay. This is negative exponent. So that is how you write your standard notation to scientific notation. Okay, and then what about changing the following numbers from scientific notation to standard notation? Okay. You have your 6.0t times 10 raised to 7. So how do you write this in your scientific notation? In your standard notation. So you write 603. Your decimal point is here. Your exponent is positive 7. So you move, or you add zeros, you move your decimal point going to the right. In this case, you go to the right if you have a positive exponent. Okay, so 7 is positive, you move to the right. So this is 1, 2, 3, 4, 5, 6, 7. You move 7 decimal places going to the right, and then you add 0. Okay, so this is now your standard notation. So that is actually equivalent to 60,300,000. Okay. For the next example, that's 5.3 times 10 raised to negative 4. You have a negative exponent, so you move your decimal point going to the left. So you write here 5.3, and then since negative siya, you go to the left. 1, 2, 3, 4. Okay. This is now your decimal point, and then you write 0 before your decimal point, and then you add zeros here. Okay. So you write this, you have your standard notation, that's 0.0053. Okay. So this is now your final answer. Okay. Here, if you are given a triangle with sides ABC, and then you are going to look for this angle. This is your theta. Let's say this is your theta, and then you are given C is equal to 5. Your B is 2 meter, and then your A, let's say this is 3 meters. Okay. Is it correct? 2 squared plus 3 squared. I'm sorry. It should be 3 squared plus 4 squared. Let's say this is 4. And then this is 3. Okay. Let's say you're given a right triangle with sides ABC. A is equal to 4 meter. 4 meters, B is 3 meters, and then your C is 5 meters. Okay. Now we are going to look for the value of this angle theta. We'll call this angle theta. Okay. So we can use your so, ka, to, wa. Okay. Since given lahat ng sides, or may value tayo sa lahat ng sides, we can use either of these 3. Okay. So first, let's try with sine opposite over hypotenuse. Okay. So this is always your angle. Dito natin ilalagay si angle sa tabi ni sine. Okay. Your opposite side, opposite ni theta here is A. Ang adjacent, the hypotenuse here is C. So you have now sine theta is equal to A over C. Okay. Your A is 4 meter over 5 meter. So si M dito maka-cancel out. Basically, wala ng unit itong numbers. So we have 4 over 5. Okay. So let's have, your number now is, your equation now is sine over 4 over 5. Okay. So how do we get your theta? So theta is now sine inverse 4 over 5. Okay, so that's how you solve it. You have now theta is now sine inverse over 4 over 5. Okay. Bakit siya in inverse? Kasi we have to transpose your sine. Itong sine na ito going to this side. Okay. So para malipat siya dito na side, kailangan natin siyang i-inverse. Okay. So you try it in your calculator, you will get 4 over 5. This one. Okay. So this is how you write it. Sorry. That's sine. Yes, 4 over 5. That is now equivalent to 53.13. Okay. We'll have it 53.13. Since this is an angle, your unit is degree. Okay, so you just write degree. That is now your answer. So let's check if this is correct by using ka. Now what if we use ka for this problem? That's cosine theta adjacent over hypotenuse. Your adjacent now here is your side B and your hypotenuse is C. So this is equivalent to B is 3 meter over 5 meter. So cancel. You will have 3/5. Okay. So rewriting this, theta is equal to cosine inverse 3 over 5. Okay. So you try it. If you solve this in your calculator, see inverse cosine 3 over 5. So this one. I think you can see. Kita ba? Okay. So you will get 53.13 degrees. Okay. So basically, parehas lang sila nito. Why? Because you can use either sa tatlo as long as given, depende doon sa given na sides. Okay, kung sino yung may values. We can also use your tangent. That's tan theta. Okay, what about using tangent? TOA is opposite over hypotenuse. In this case, the opposite natin is your A, and then, I'm sorry, TOA, it should be adjacent. Opposite over adjacent. Your adjacent is B. Okay? Ganyan. Okay, and then, your A is 4 over 3f. Okay, so you can write it, theta is now tan inverse 4/3. Okay, so you solve it, tan inverse 4/3. I'm sorry. Oh, okay, so you will get the same value, that's 53.13. Okay. So basically, pare-parehas na yung sagot nila. It's because you can use these three functions simultaneously depending on the given. Okay. So kapag hindi given si C, for example, wala tayong value for C, you can use your TOA or your tangent opposite over adjacent. Okay. Kapag wala naman tayong given na B, so you can use your SAW. If walang given na A, you can use your cosine. Okay. So it depends sa given on how or on what trigonometric functions you're going to use. Okay? Now what about for the laws of sine and cosine? Okay. So let's use first your law of sine. Okay? So you have your A given, a triangle ABC. You have to solve for the missing parts. So in this case, your missing parts is, I think you have to look for the value of your angle C and then the value of your sides B and C. Okay, so ito yung missing parts. Ito, tsaka ito. Okay. Okay, so first we'll start with solving for angle C. Okay? Since we all know na ang sides ng all angles of your triangle must equal to 180 degrees. Okay, so all you have to do is you add your angle A and B and then subtract it to 180 degrees. Okay, so let's first add. So C is actually 180 degrees minus the sum of your A and B. Okay, so have here 180 minus your A is 32 degrees plus 81.8 degrees. Okay, so your C now is 66.2 degrees. So ito na yung answer. So that's how you look for your angles. You just simply subtract the sum of your two angles. Okay. So take note, kapag in-add nyo lahat ng angles ng triangle, it is equivalent to 180 degrees. Okay? Okay, now what about for solving your B? Unahin natin sa side B. Okay, let's solve for solving for side B. Okay, this one. Okay, so we are going to use your law of sine. Okay, so which, diba meron tayong yung law of sine natin, that's A over sine A, B over sine B, and then C over sine C. Okay, since hindi given si C and C, ito yung gagamitin nating relationship. Okay, si A over sine A is equal to B over sine B. Okay, so you write it here. So we have A sine A is equal to B sine B. Okay. Tapos, yung hinahanap natin is B. Tama? Okay. So you write it this way. B is equal to this one. Okay. So that's A sine A. Okay. Saan niya yun si sine B? Okay. Since sine B is the denominator in this expression, okay, you try to multiply both sides by sine B. Para ma-cancel siya dito na side. Okay. So kapag na-cancel na siya dito, si B na lang yung maiwan. Which is now equivalent to B equal to A sine A, this one. Ito na yan siya. Times sine B. Okay. Okay. So this is now sine B. So ito na yung formula na gagamitin natin. Okay. All you have to do is substitute the given values. Okay, B now is equal to, okay, so A here is 42.9 over sine 32 degrees. Okay, and then you multiply it by sine 81.8 degrees. Okay, so you input this or you plug in this in your calculator, you will get 80.1 cm. Okay, so mare-retain si cm natin na unit kasi hindi naman siya na-cancel out. Okay, so yung nawala dito na units are your degrees. So your answer now here, or your side B, is equivalent to 80.1 centimeter. Okay, so meron na yan dito. This is now 80.1 cm. Okay, so kanina si C, that's 66.2. So this is 66.2. Okay. Now we are left with C. Okay, so si C naman yung isa-solve natin. Okay. You can use either of the three equation. Okay. Or the three laws of sines. Depending on your choice. Pwede nang gamitin yung tatlo. Or, I mean, depende kahit saan dun sa tatlo. Since given na lahat ng sides. I'm sorry. We are looking for side C. Okay, so ito na yung hahanapin natin. So, I'll have C sine C is equal to A sine A. Okay, so, pwede yung pagbalik-balik ta rin yung formula na binigay ko since it is equal naman. A sine equal, A over sine A equal B over sine B equal C over sine C. So, pwede yan silang pagbalik-balik ta rin. Okay. Since we are looking for C, itra-transpose natin si sine C dito na side. Okay. So, how? Dapat makancel muna siya dito na side, sa left side ninyo. So, to cancel out sine C in this side, you multiply both sides by sine C. Okay. So, para mag-cancel out siya. Cancel, cancel. So, you will be left now with C equal to A sine A times sine C. Okay? You plug in the values. Your A is 42.9 cm over sine 32 degrees times sine, your C is 66.2. Okay, this is from your yung sinolve natin kanina na angle C. Okay. So, you will get 74.1 cm. Okay. So, mariretain si cm na. Okay. So, this is your C. So, I'll write here C is equal to 74.1 cm. Okay. So, that's how you use your law of sines. Okay. Now, what about for the law of cosine? So, how do we use law of cosine? Paano natin siya magagamit? Okay. So, let's say you have here an example. Solve for the magnitude of angle ABC if A is equal to 34 feet, B is 20 feet, and C is 18 feet. So, in this case, walang given na angle. Okay, unlike kanina kay law of sine, meron tayong given na angle. Okay, at least one angle. Dito kasi walang given na angle, but all of your sides are given. So, how do we solve this one? Okay. So, ang hahanapin natin dito is si angles. Angles A, B, and C. So, how do we solve for the angles? Okay, so let's start with angle A. So, unahin muna natin sa angle A. So, solve for A. Okay. So, which of the following laws are we going to use? So, yung first ang gagamitin natin kasi yun yung merong cosine A. Okay? Andun si angle A. Yung big letter A natin. So, you will use A squared is equal to B squared plus C squared minus 2BC cosine A. So, since we are looking for this A, so itra-transpose natin yung mga yung mga variables on the other side. So, we can have it, or i-transpose natin ito. This whole number dito sa kabila. Okay. Let's transpose it to the left side. So, you will now have two BC cosine A is equal to, plus A. This A squared plus A squared is equal to B squared plus C squared. Okay. Again, since this is negative, pag ilipat natin siya dun sa kabila, magiging positive na siya. Okay, that is why we have here positive. Now, we transpose A squared naman going to the right side of the equation. Okay. So, ang mangyayari, you have 2BC is equal to 2BC cosine A is equal to B squared plus C squared minus A squared. Okay. Magiging minus na siya or magiging negative na si A squared pag nilipat mo siya dito na side. It's because it has a positive sign dito na side. So, kapag i-transpose natin siya sa kabila, magiging negative na yan siya. Okay, so, we have negative A squared here. Okay. Now, we divide both sides by 2BC. Okay. Bakit? This is for us to cancel out 2BC here. Kasi dapat yung matira, si angle na lang. Okay. So, your equation now becomes cosine A equal to b squared plus c squared minus a squared over 2bc. Now you plug in the values or the given values. You have 20 feet squared plus 18 feet squared minus 34 feet squared. Okay? From this one. Sige, wait lang. Ayan. Okay, so dyan galing C values. Divided by 2 times 20 feet and 18 feet. Okay. So you will get negative 0. This is negative 0.6000. Okay. So yun yung makukuha niyo value if you solve this one. Okay. Now, bakit wala na siyang unit? Take note, if you multiply this one, or if you square this one, you will get feet squared. And then if you add the rest, feet squared ito siya sa itaas. It will cancel out with your denominator. Your denominator will have feet times feet, that's feet squared. So, maka-cancel out si units natin. So, wala na tayong unit pagdating dito. Okay. Now, this is cosine A. So, hindi pa natin nakukuha yung angle. Okay. So, how to solve for the angle? You will have your inverse cosine. Cosine inverse, negative 0.600. And then you will get 127 degrees. This is now your answer. Okay, this is now your angle A. Okay. So for angles B and C, I will leave it to you. Kaya nyo na yan, guys. You do the same process. Okay. For the angle B, you can use b squared is equal to a squared plus c squared minus 2ac cosine b. And then for angle C, you can use your law of cosines na equation